Almost. Welcome everyone to this Observability Clinic, Mastering Kubernetes Resiliency with Dynatrace. My name is Henrik Rexed, but the star of the show today is Mr. Henrik Rexed. Henrik.
Welcome everyone. Thanks for joining this webinar. I hope you enjoyed it because I enjoyed it preparing that content.
Yeah. Henrik, I know you have a lot of content. It's about Kubernetes resiliency. I think we have a lot of our folks that are attending live or watching this recorded that are interested in everything around site reliability engineering, performance engineering. The question is, how can we make Kubernetes clusters resilient? But also, I think one of the concepts you are showing us today is not for every price. So you also want to be cost conscious. But what have you prepared for us, Henrik? I think that's always the way we get started.
Yeah, good point. So because I come from the background of performance engineering, I basically did lots of load tests, to be honest, and I started to enjoy tuning up this application. So here I'm using a demo application, but I'm trying to replicate to replicate a story that happened from an organization, e-commerce website, in fact. And here we're going to talk about the costs. Not only the costs, people always think about cloud costs, about dollars, but also consider the fact that if your workload are less expensive, then at the end, you are consuming less power, you're consuming less energy, and you're more green. So it's not, don't just take the cost angle. Cost will be a driver to optimize and be more efficient. So we will look at the impact of having not unoptimized resource in our cluster, specifically if you use Kubernetes. It was of course, an excuse for me to share all the latest and greatest work that our R&D has worked specifically on the Kubernetes support. So you may have seen them probably if you are using Kubernetes screens, but I want to remind you what had happened during the last month. So then everyone is on the same page and you can take probably advantage of those features if you didn't realize that we had implement those new stuff. And last, you will see that sometimes even you are able to optimize, sometimes a container is a container or a pod is a pod. And if you want to take more load and still be more efficient and cost effective, then introducing autoscaling will make sense. So we're going to talk about autoscaling here and see how autoscaling works with the default rules in Kubernetes. And the idea is then, how can we be more efficient and not relying on the default metrics, but using, for example, Dynatrace as a metric source for our autoscaling policies. So lots of content. So I suggest that we start. So let me introduce the story. So I'm not going to reveal the name of the organization, but the story is simple. So this organization, the e-commerce website, they were working on a release. They spent a lot of time building, testing, making sure it's reliable, and then to deploy the app. And they had few issues, but overall, the application was working properly. No major performance problems. The load of the app was quite stable. They were expecting some spikes, but for the moment, the current version of the app was pretty suitable for the traffic that they were dealing with. But so the team was working for new features, but one day, one person gets in the office and says, I look at the cloud billing here and it's way too expensive. So, okay, guys, you did a great work. You implemented the right app. But as of now, what we want for you is to try to consider optimizing a bit more your resources. So then we can basically have the right balance between a good app and also a cost-effective app. So they started to do that in venture. So before to understand the fact on how you can optimize our resources, I think it makes sense that for all of us that we remind us what is actually causing the costs in our cloud providers. In fact, as in general, when you talk about Kubernetes, Kubernetes is like an onion. There's the different layers. And the way we are being charged by our cloud provider depends on different dimensions. The first one is, of course, the cloud provider is managing our cluster, providing master nodes for us. They manage the master nodes. So they will add extra fees because they manage the overall cluster. Then, of course, if your cluster starts to do some internet communications or communicating with workloads sitting on another region, another zone, they will be also charged. And then if you go to the cluster itself, the size of the price of the cluster depends, of course, on the number of nodes that you rely on, the number of cores that you need, the number of memory. I mean, you know that. I'm not going to, nothing new for you. And of course, the other angle is the PVC. So if you requires the persistent volume claims, the price of the persistent volume claims depends, of course, on the size of it and the number of PVCs. And last one is the networking. So if you do any ingress rules, or if you do any services in Kubernetes with a type load balancer, then it will basically allocate an external IP address, and those external IP address doesn't come from free. So it will also charge that piece. So this is the different angles that we need to consider when we need to optimize our cluster. So at the end, if you understand pretty well, I can basically review the size of my node, but again, it will be complicated for the organization. It means that I will have more clusters to deal with. At the moment, my cluster is, I have my app, but also other applications. So I don't want to have it go into a journey where I'm going to change everything. I want to reuse the actual size that the operator comes up with a certain number of cores and memory. So I don't want to go on changing the node definitions. The other thing is the persistent volume claims. But in my case, in this particular app, I don't use PVCs. So I don't need to resize the PVCs. So the last thing that is left is try to resize my workload. So what does that mean? If you remember well, I talked about it in last year or other events. When you deploy your workload in Kubernetes, you have nodes that has available resources. So it's basically, it's what is potentially what you can allocate on that node. So you have a maximum memory, and when I deploy, as a consequence, what would happen is that based on the definition of my resources, then based on the request definitions, Kubernetes will basically allocate those resources. So if I have every deployment requires 1 core, and I have 10 of them, then I have consumed 10 cores. And if my cluster has 15 core, it means that I only have 5 core left for the rest of the workload. So maybe I'm not very gentle with the other applications, so they are not able to be deployed because there is no core left for those applications. So this means maybe with the requests, when we deploy, we need to pay attention of what we actually using. You can see here the usage is way lower than what we requested. So at the end, if I look at the usage here, I have an average usage about 10%. Maybe I can consider the fact that I can optimize a bit. So how you optimize, at the end, the journey is very simple. You look at your usage versus what you've requested. And if there's a huge difference, then yes, let's reduce the requested CPU, the requested memory, and maybe I will be more efficient for other projects to allow them to be deployed in that same node. So at the end, we are optimizing a bit the way we utilize our nodes. And last, of course, we should look at the usage versus the limits, but at least with the requests, you're going on the right directions. So let's start with a small demo. I want to show you the actual version of the app that had in the past already requests and limits defined. And we'll see that how we're going to optimize it. The journey on how we're going to optimize it will be based on different things. So first of all, this is the link to, I should have placed the QR code, I'm sorry. But this is the link to the GitHub repo that has the entire demo that I've prepared for you guys today. At the end, to summarize, there will be, of course, the Dynatrace operator, the hipster shop. I will use the hipster shop because I want the one agent to instrument the hipster shop. And then I'm going to rely on a CNCF project called OpenCost. So OpenCost is initially comes from KubeCost, and then the other people has contributed to that. So it's a free version of KubeCost, providing, of course, less features. But at the end, what we're interested in is the actual cost, and OpenCost will give it for me. So even if it's not real, it's estimated cost. At least it's a KPI that I can look at on a daily basis to make the right decisions. So let's jump into Dynatrace. So
And by the way, Henrik, I just posted the link also to your tutorial, just to let you know I'm still here. I'm trying to make sure that everybody that asks questions in Q&A gets the questions answered, whether it's technical questions or not hearing us audio-wise, it seems that's to be fixed. Whether it's any other questions, please use the Q&A feature. And I also try to post in any links that are relevant for what Henrik is showing as he's walking through it in the comments. So yeah.
So two things I've done here. So first, to be able to measure the efficiency of my cluster, I could have looked at production usage, but here I've defined a K6 dashboards with metrics coming from the load testing solution called K6. So I have the virtual users, the hit per second, the throughput. So if you do performance engineering, you know what I'm talking about. And then I have the response time. So at least with these dashboards, with the different experiments or tests that I will run, I will look at the results and basically see if the response time is good from a user perspective, and then make the right decision. So that's the first dashboard that I'm going to utilize. The second dashboard that I'm using here is the cluster efficiency. So as you can see, we are in a new platform with Dynatrace, and I'm using the we call say that the classic dashboards. We can even name it the vintage dashboards. I don't know. What do you think, Andy?
Vintage sounds actually not too bad. Yeah, you're right. Maybe we should post this to Thomas Zingbeck.
So it's collector dashboard. Oh no, listen. So yeah, so here in that dashboard, what I did, I tried to bring the cluster in different layers, starting from the pod, not the pod, workload, sorry, and on the second layer, more on the namespace level, and the last piece on the node. What I tried to calculate here is the efficiency of my workload. As you can see here, I have some green. So of course, because I'm based on the requests, I can still consume more than I requested. So that's why you have a value above 100%. But what I'm chasing for is workload that are less than 70%, for example. You can see that we have the shipping services from the hipster shop, which is 7.6. We have that's load testing, so I'm not going to optimize load test. We have the email sources with 6.2. We have product catalog with 59, so we are still under 70%. So there is lots of workload that is red. So it means in terms of CPU definitions on the current version of the app that I have deployed, that is working in production, I can do better. I can be obviously better. So with this, I can basically look at which workload. And the great things now with, I don't know if you pay attention on Dynatrace recently, but now this is a dashboard, a customized dashboard that comes in by the way, on the GitHub repo. If I click here, I can jump into the workload on the time frame and look specifically on that pod and have more information. But that's one of the features that is available since a lot of time, but I just want to remind that. On the memory side, you can see same thing. I have a couple of workload that I could optimize. So I'm paying attention on the throttling. So we will cover that later on. It will be a very important indicator. I can see that a couple of I have no major, I say, throttling here, except few services from the hipster shop. But the most important thing here is the cost, and the cost comes from open cost. So first, you can ask yourself, how did you import that metrics? Well, if you paid attention, I mean, I'm pretty sure that you paid attention to that, and it's just a reminding. With our operator since a year and a half and more, we had the options to scrape Prometheus metrics exposed on application providing Prometheus metrics. So what I did here, open cost has a open cost services. I just simply introduced those annotations, and as a result, we got those metrics back in Dynatrace. So this is how I'm able to do this dashboard showing me the monthly cost. So here you can say, hey, $8 is not a big deal, but imagine that you have a 10 or 20 different dashboards here. It could be quite expensive. So here you can see that the most expensive workload in this giving cluster is obviously the hipster shop. So I will have to optimize it. So how can I optimize it? Well, I can simply modify the request and limits. All right, good. So this is what I did. Let me share some results. Let's go back to the slides. Let me share some results. So this is what I showed you. I had 8.9 costs. We had a slow test going to 260 users, but I cut down the load because my app is not supporting that. I knew that from production perspective that from 100 users here, you can see that we have the app is not stable in anymore, and we have obviously pods that are not responding at all, which is completely dark. And as a consequence, once we reach that time, then we have a response time which is unstable. No surprise, we know if we have less an unstable workload, we expect to have these problems. And what was important here, the response times were almost stable, about a couple of seconds for most of the URLs of my load test. So now what I try to do, I wanted to optimize. The first thing I did, I say, okay, what I'm going to do, I'm going to remove the request limits from my this version of the application. And now I'm going to show the results. So first of all, we can see the same thing. Now we can consume more by the way, sorry, this is the CPU usage. You can see that we are able to consume like 800 millicore with the previous versions. Now, if I apply the request limits, you can see that we don't have the same graph anymore. We are consuming a bit more than 800 millicore. The response times is obviously super stable. That is fantastic. And the cost also is quite good. But as you know, no surprise, it's a recommendation. Request is a recommendation, and we're going to talk about it in a few seconds. So this is not the ideal situation. Even if the numbers are great, we want to be close to that situation by introducing request limits. So what I did, I tuned a bit. So I'm not going to chase for more than 100 users. I want to be as equivalent as the level of performance that we had before. And this is what I got. So here at 100 users, I am consuming 200 millicore. So first, I'm more efficient in the usage of my CPU. And you can see that we have this weird curve up and down, up and down, up and down. And in terms of response times, we are much, much better than initial version that we had. And the cost, we went through almost $9 to $3.2. So at the end, and the efficiency of my namespace is at 87%. I say here, I can stop working, go to my vacations, go close to the pool, and stop the webinar. I think we can stop here.
Sure.
No.
Bye-bye.
But no. Why? I'm going to tell you, why do we have those spikes? So let's understand. And if you go back to Dynatrace, I can show you and go to the time frame where we had this load test that was this morning. Here it is. This is the one. We have the exact curve that I showed you on the graph. But what's important now, if I go to Kubernetes, you will see up. I have some bunch of alerts here, by the way. And you can see, not monitoring available, but we have a high CPU throttling on the front end, on the ad services. So all those unstable graphs were detected by Dynatrace, and those basically during the moment we were unstable, we had lots of throttling, which was causing this unstable version of the app. So let's talk about request limits. Even if I talked about it, I want to remind it because it's very important. Requests are important because the way we schedule our workload, the way Kubernetes schedule the deployments and your workload on your cluster is based on the request definitions. So it takes your workload, look at the request and say, okay, do I have a node where I can place this available? Do I have any CPU here in this node? Okay, I'm going to place it here. So it's exactly like a Tetris game. So if with the requests, he sees different shapes with different size, and then he will move those shapes, place it on the right node, and he's winning points. So Kubernetes is happy about it. But if you remove, like I said, I removed the request limits, we had good performance. That's true. But again, Kubernetes sees our workload coming down with all the shapes are the same, small, tiny shapes. He's tried to place it on one node, and at the end, he realized that this node, this resource is just increasing, and then we have no CPU left. So you're not helping Kubernetes to do the proper job. So requests is obviously a recommendation from the industry. So how do you express it? CPU in millicore, memory in bytes. If you do the right tests, then you can find the right values. And if the value is too high, like I showed you before, we won't be efficient with the resources. Those CPU, those memory will be allocated, and no one will be able to use it because you have placed those values too high. On the limit side, and this is where the throttling comes in the picture, if you don't, your limits will be the contract with Kubernetes, how many water I can consume in that apartment per month, or how many power consumptions I can use per month. And so you need to define the contract with Kubernetes, says how much a maximum resource can I consume. And in memory, it's very simple, it's in bytes. So if you do the right load test, you can figure out how much memory max I can set in that specific pod. And that's it. If the value is not defined well, then we got OM kill, you know about it, but at least we know why it's been killed, because the value of the limits is too low. On the CPU side, it's different. You know, the way we share resources within this server, this node, is based on a containerized context. And in Linux, there is a notion of C group and CFS. This is how we share CPU cores between the server. At the end, you have a CPU with different cores. And then every CPU with all the cores that are in it has CPU cycle. So a cycle of a core is 100 milliseconds. And then when we define the limits, we don't define how much core we want. We're defining how much time I can consume in a CPU cycle. So if I define a CPU limits of 20, it means 20 milliseconds, which means I have a cycle of 100 milliseconds. My workload will be able to work during 20 milliseconds. And then even if I didn't finish my task for on my application, the system will pause my pod or my work, and then we will wait until the next CPU cycle. So during 80 milliseconds, we will wait, and then we will restart and resume our work. So this mechanism of working and posing and working and posing and working and posing like this, which is, you can imagine, is not very good for our systems. This is called throttling. So throttling is impacting so much the behavior of systems. So don't underestimate it. It's very important. Mm-hmm. So that's the small reminding. And let's talk about how Dynatrace can help us. And if you paid attention 1 year ago, I was sharing the news that we were starting to introduce out-the-box alerting in Kubernetes. And since the 1 year, we've been releasing over each releases new out-the-box alerting in Kubernetes. And this is basically the different alerts that we're going to cover. So again, let's talk about the onion on Kubernetes. The first layer is the user sitting outside, and all the things about response times. If the response time starts to jump in the roof, then it means that we have throttling. So response times is a crucial KPI for us. Failure rates, if we start to have a lot of failures in our systems, maybe there's a pod that has been OM killed. This is also a way of measuring it. And then cluster. So is the cluster up and running? Do we have any CPU saturation globally on the cluster? On the node, we're going to check the CPU request saturation, memory request saturation. Do we have too many pod running on that node? On the namespace, if we have defined resource quota, we're going to look at the quota itself and alert you if you have overconsumed those quota or you're close to overconsume those quotas. And last, on the workload, we want to pay attention on pod restarting, unable to schedule, pod pending, pod OM kill, throttling, all the things that we want us to be alerted in time to make the right decisions. And that is done automatically by Dynatrace. Like I said, we've been adding more and more out-of-the-box alerting. Maybe you've seen it. If you don't, then take advantage. It's awesome. The great thing about this feature is that you can define it at the tenant of Dynatrace, which means all the cluster that you will connect will have the same anomalies detections for all your clusters. But then there's always someone in your organization say, hey, I'm different. Yeah, I know you're different, but why? Yeah, I'm doing machine learning and I'm consuming more CPU. I have different requirements. So don't put the default alerting for me. All right, good. So which means now you can go to that cluster and change specifically those thresholds for this specific cluster. And you can do the same thing from the namespace level. So it's very flexible. You can customize on different layers. And so it's make your life easier when you have to deal with the anomaly detection rules in general. The other great things that we introduced, and I love it, to be honest, but maybe it's more for the people managing the deployments of your cluster and Dynatrace in general. When you deploy Dynatrace in a cluster, there's two information: the connections and the monitoring. And these two screens those two information were in the same screen. Now we've decided to split it. So there is a screen for the connection, so how you connect to your cluster, and there's the settings for the monitoring. And the monitoring, remember, this is where you define, oh, I want to enable Prometheus exporters, I want to enable the workload, the events, and so on. And remember, in the past, every time you add a new cluster, you had to go to the cluster settings and enable that. You can do that from the API perspective, that's true. But again, it will be perfect if we had the option to say, globally for all my cluster, I won't have this. And now this has been done. You can customize in the tenant how all your cluster that will be added in Dynatrace will be monitored. And then, of course, for each given cluster, if you want to change slightly your monitoring requirements, you can do it, similar to the alerting. The other thing also is we provide an operator that has different containers, the active gates, the code module, so it's the agent that we inject in the pod, the agent that instrument your nodes, the operator. So there is different components, different containers, and at the moment we were relying on the registry where we're providing the images. And people sometimes they want to have their own security process and respect the organizations. And now what we've introduced is the way that you can pull out our images, store it in your private registry, and run your own security scans. And on the latest version of the operator, you can also have the SBOM file. So which means if you want to do some security scans on the SBOM that we provide, you will be able to do that. So we are more aligned even with your own security requirement that you may have internally. Last other aspect, it's almost the last piece. I don't know if you pay attention, but recently most of the cloud providers started to use immutable operating systems. There are 3 immutable operating systems out there. There is a Flatcar, there is Bottle Rocket from Amazon, there is Talos, and those immutable operating systems, they provide some advantage. It's more secure. You only have read-only access on the node. You cannot write anything anymore. You can just read. So it's bringing like a sort of security, avoiding having third-party programs writing stuff and destroy your cluster. It's easy to upgrade because at the end, nothing is written on the node, so you can remove it and replace with a new node. So there's a couple of advantages of that. But how you observe it? I mean, we cannot write anything on the node. This is then it's going to be complicated. Well, good news. The operator support that. So we rely on Prometheus metrics, and we provide on, of course, of the different components that we provide with the operator. I mean, at the end, all the experience that you have from the node analysis screens, from the pod, from the namespace, all those information will be there. You will also have Davis picking up specific problems related to this immutable nodes. So we support it very well. So if you're moving to a cloud provider providing those immutable operating systems, yes, you will be able to rely on Dynatrace. So I talked a lot about different features. It's better to show them than just show slides. So let me go back to Dynatrace and show you directly those different features. So let me go back. So here is the second gen, sorry. Here is the settings. So I'm going to go to the settings of Dynatrace. And I talked about the anomaly detection rules. So if you go to anomaly detection rules in the settings, you can see that we have Kubernetes, and there is different layer cluster. There is cluster, node, namespace, workload, and so on. And you can see that those, if you didn't pay attention, first make sure to enable them. It should be enabled, but if you not, maybe it will be great to enable them. So globally, all the cluster will have those anomaly detections available. And then, of course, I can go to each of those layers, node, namespace, workload. And you can see on the workload, we have a different alerting about CPU throttling, the memory usage saturation, the pod stuck in terminating states. This is pretty cool because it happens quite often. And then you have all the things about job failures, out of memory, pod backoff, eviction, and so on. All those will be enabled on the tenant. And of course, if I go to my cluster, let me go from this the new platform. If I go to my cluster, I can go to the settings of this particular cluster. Oh, and let me talk about the connection settings afterward. And I can customize. I can basically overwrite the settings that we have placed in the tenant of Dynatrace and customize those thresholds specifically for this cluster. And you can do that, of course, if I jump into namespaces, I will be able to put specific alerting for a specific namespace as well.
And Henrik, just to quickly also mention here that these settings can all be configured as code. That means all the settings are settings 2.0. That means we have an API. We can do it via Terraform. You can do it via Monaco. You can do it however.
Yes, a good point. I didn't mention that, but obviously, yes, that's very important. Other aspects that I mentioned is the connection. Remember the settings of your Kubernetes, you had the connections, and then on the bottom you had enabling different monitoring features. Now those are splitted, which means this is on the settings on my tenant on my cluster, sorry. But you can also enable it globally. So which means every time you have a new cluster coming in, if you go here to cloud and virtualization, Kubernetes, you can basically here set globally what I want to enable for all my cluster that will be added in Dynatrace. I want to enable those features. And this is great because I mean, if you operate 10, 20 or 30 clusters, it's quite annoying to modify, to enable each of those toggles one by one. One thing maybe you didn't pay attention, and I didn't do anything about this. Something great. Previously, I showed you some alerting about throttling. This is the out-of-the-box alerting that I showed you. But one thing that I'm super excited about is what we do with the where is it? Is the fact that when you enable workload metrics, we start to interact with the C advisor. Usually on a cluster, there's always a C advisor pod, and that C advisor pod provides a lot of information about the container. And this is how we have come up with new metrics about the usage on the pods, on the workload by workload or by node. And that basically give you more insights of what's going on. And also just to remind for those who never played about it, but you have Davis inside. So here, for example, I see that I have some throttling here. Then I can do, I want to see who is generating that throttling. And it says, its recommendation service was generated that. Oh, great. So then I know which pod I need to optimize. So again, because we get those metrics from the CA advisor metrics were more precise, which means now you can use Davis Insights, so a proactive way of using Davis to help you to point out what should be optimized. And especially in the case of today's session, if you want to remove the throttling, then it will guide you on what is generating that throttling and which pod you should optimize. All right, I talked a lot. Let's go back to the slides. Now, I came up to a version. Remember, if I go back to the load test results that I had here, this is the version I have. Oh, I can show you in Dynatrace. It would be even better. Yes. If I remove that filter and go back to the preset, and the test was done this morning between this one, 10 to, no, it's not really this one, but it's a time frame. It's a longer time frame, but never mind. What I decided is I want to keep the cluster efficiency of that settings. I'm pretty happy about it because I have a pretty low number. But I know that from 100 users, I am getting problems because due to CPU throttling. So I'm not going to chase about the problem. I think if I add more pods to the strategic workload of my app, then I could resolve that. Having more pods, then the pod will do less work and not reach the limit anymore. And maybe I can basically be able to take more load. So let's try to autoscale this application. To autoscale the application, Kubernetes provides an awesome feature called horizontal pod autoscalers. It's out of the box when you deploy Kubernetes. It's out there. It's called HPA. Pretty sure you know about that. And without HPA feature, you can basically create rules on your deployment, on your replica set, on your stateful set, to basically increase the number of replica that you need to handle the load. So at the end, instead of like one single replica or fixed replica, it's going to be dynamic based on values. But again, you will see it's not ideal. Why it's not ideal? Because at the end, it's relying on the HPA to be able to take the decision on the number of replica required. It's based on the metrics available on the Kubernetes API. And by default, the Kubernetes API provides only two metrics: the CPU usage and the memory usage. So in our case, okay, I know that's the limitation of HPA, but I'm going to still try to do that. So let's have a look at what we've done. To be able to autoscale, I'm not going to scale the 12 pods of the heap shop, doesn't make sense. So I'm going to focus on the pods the workload that is critical for my application, the core components. So the checkout, obviously, because if people are not able to do the checkout, then I'm losing business. I want to make sure that people are able to pay. That's an important feature for the business. I need to make sure that the cart, people is able to add a product in the cart. The product catalog with the different product is responding and recommendation. So that's going to be the main workload that I'm going to focus the auto-scaling piece for today's webinar. So before I'm sharing the results, let me show what I did. So there's an HPA folder here, and the HPA is going to be based on CPU. So what I've decided here, I said, okay, I realized that after a certain level of CPU utilization, again, it's not really reliable metric, but because I only have CPU utilization, I'm going to, I saw that after 70%, I start to have throttling. But again, it's not a real science, it's just a guessing. So I decided to do, for every time I reach 70%, I want to add one extra replica, and the maximum replica will be 10. And I did that for the front end, from the checkout, from the product catalog, and all the various services. So what do we have that? So let's have a look at the results for this particular test. So here, this is the test that I did at today at 1:10. Yeah, this one. So at the end, if you look at this at that time frame, you can see that I have the similar cost. So we're pretty good. So again, I'm still respecting the efficiency is still there. So I'm pretty happy about that. But let's have a look at the response times. If you look at the response times from a K6 perspective, I have, first of all, the good news, I was able to reach out more load. So that's great. And then before that, after 100 users, we had like a very unstable response times. And here, after 22 at 121, here it is. It's about here at 100 user, we had issues. Here at 160 users, we are still delivering suitable response time. So it's great, but you can see after that there's like unstable problems. And why do we have unstable problems? Well, I simply have to look at the out-of-the-box alerting, and what I see here, I see again CPU throttling on the shipping services, on the checkout services, on the recommendation services. So all the things that are, even if I've applied, so if I look at the front end, I have lots of pods. That's great, they are running, but I have lots of throttling. So I'm not the decision to auto scale based on CPU is obviously not efficient. So how can we make more efficiency? So let's compare the results. So this is what we had before HPA, and then we introduce HPA. So the cost is a bit increased, but again, I'm having more workload. But you can see here, after that moment here, we start to have unstable response times, and this is due again to throttling. So why don't we, instead of using CPU usage, in my particular case, why don't I use throttling? Gosh, it will be so helpful. But again, oh, yeah. So that's the
You
throttling.
mean response time, right? Why don't you use response time for?
I could also use response times. That's true. But in my particular example, I decided to use CPU throttling.
Throttling. Okay. Yeah.
But that was my decision. But response time could be also an indicator, or you can use also the number of hit per seconds. If you know how many hit per second starts where you start to have your services going to start to behaving in a weird way, you can do that as well. But how can I use external data to build my HPA? Well, good question. And I know Andy has the answer because you presented that on different conferences, and you're talking about it. But the answer for that is Keptn. Yes, remember, Keptn has a new version. It's an operator that you deploy in Kubernetes. It provides tons of new features to do pre-deployment checks, post-deployment checks. So you can basically deploy and make sure that everything is working expected. You can define this notion of application, do post-deployment checks on the overall application that is made of 10 or 20 services, and post-deployment check as well. So all the things that we need is there, and also provides also out-of-the-box DORA metrics. It provides traces on your deployment. So many features. But one feature that I was interested is the metric server. The Keptn operator provides a metric server. And what's the value of this? Yes, we want to have custom data. And you can say, oh, yeah, but you mentioned that I'm an expert in Kubernetes. Yes, Kubernetes provide out of the box only CPU and memory, but you can deploy adapters. Yes, I know adapters, but remember, if I have Dynatrace, I have Prometheus, it's two different sources. I can only have one adapter per cluster. So I cannot rely on two sources. And if you have different sources of information and you want to make the HPA or any use cases that are based on Kubernetes API metrics, then the metric server of the Keptn will help you to achieve that. Basically, you can create new providers, and those providers will connect. So Keptn will connect to the solution of your choice, Dynatrace, Prometheus, collect the data and expose it to the Kubernetes API, which is fantastic. This is exactly what I needed. So how can I take advantage of that? Well, first, I have the metric server of Kubernetes. I have my deployments. So first, I will have to deploy the Keptn lifecycle tool, the Keptn operator in my cluster. And then to be able to connect to Dynatrace, this is what I want to do. I will define a metric provider. So a metric provider is a new CRD. I'm saying, oh, I want to connect to Dynatrace. Here is the URL. Here's the API token. So I need to have the right API scope on the token. And then I can, once the metric provider is done, I can define my metric. So defining my metric expression, if you use metric expression, but you can also do DQL because we have also DQL source metric provider. And then I can just simply create my HPA based on those metrics. So let's have a look at that. So now in this particular case, I'm going to use Keptn with the metric server. So let me show you the configuration. So if you look at here, I have a Keptn folder. I have the metric provider. So I'm creating the DQL version. So I could have done DQL as well. And I can do the traditional one. What I did, once I've defined those metric provider, it's already deployed in my case, I define my metrics. And in my case, I wanted to measure the percentage of CPU throttling that is happening per workload. So here it's the metric expression for the recommendation services, for the product catalog, for the cart services. And once those metrics are available, then they are available as a metric. So I can show you, for example, I can make the query. Where is my command line? Here is my command line. Tick. And if I do get Keptn metrics on the hip to shop, come on. Okay, well, once it's been finished, I can continue. But it will show you values at the end. Those metrics is exposed on the Kubernetes API. You can query them from the CRD Keptn metrics. Here it is. I got it. You can see that I have some values here. So I basically now, because it's an available value as a metric, I can base HPA rules. So once I have that done, the metrics are there. I can simply create a new HPA. And now the HPA will say, I'm going to refer to an object, which is the Keptn metric, and the name of my metric that I want to rely this HPA rule, and again, the value. So here, if I have 100% of throttling, then I will start adding more replica. and I decided to go to 15% because I'm consuming, at the end, I'm more efficient. I'm requesting less CPU, so I can add more pods at the end. So that's the good news about it. So I'm looking at the time and I want to have a Q&A. So I'm not going to show you in Dynatrace, but I'm going to show you the results. So here is what we had with HPA, traditional HPA, based on the CPU usage of 70%. And now by introducing the Keptn metrics based on throttling, but again, like Andy mentioned, we can do it on response times. You can see here, 2.6. We are even cheaper. We have more pods running. We're able to take more load, and we are more cheaper. So at the end, I deserve vacations now. I don't need to work. I did my job. So here you can see that I even was able to get a longer screenshot because I was able to handle more load. So instead of being blocked at 150 users, I was able to reach to 245 users, and you can see the response times. I mean, here the scale is not the same. But it's almost stable. Again, I have I can optimize a bit the rule by combining different metrics to avoid those unstable, those spikes you can see here. But at the end, I was more efficient. And that was the goal. I am still having the same release, better resource utilizations, and better auto-scaling policies. So at the end, it's a win-win for us. So as a takeaway, to move to the Q&A, so again, define request and limits. This is, I mean, it's a recommendations. Put resource quota on your namespaces. It's very important. Don't rely on the default metrics exposed by Kubernetes metric API for auto-scaling. It doesn't make sense. And you could also jump into major problems here. I didn't have the problem, but if you add more and more pod because the rule is not efficient anymore, you can impact other workload. You won't be able to schedule potentially other workload. I didn't talk about that problem, but it's a real problem. So try to use the Keptn metrics to extend the Kubernetes API and extend your HPA to have more suitable HPA auto-scaling rules for your applications. And again, open cost is open source. Why don't you use it to add these cost angle in your decisions, in your load tests, and measure on day-to-day basis your efficiency of your workload, so then you can optimize and be more smart, and you will be able to enjoy the sun and the heat that we are currently having in the south of Europe, at least. Is Observable, small teaser, the channel, for those who never heard about it, it's the YouTube channel about observability in general. I provide different episodes on different topics, and auto-scaling is one of them. So check it out, it's out there. And I need feedback, so don't forget to watch some content and send me a message, say, hey, it sucks, you should do better. And if it sucks, I should try to change, obviously, the content. All right, so lots of slides. Do we have any questions?
Wow, first of all, Henrik, I want to say thank you so much, because when I saw your slides in the beginning, I reminded you, well, it's a lot of content. Will you be able to get through it? And you did in your classical fashion on how you do it also on Is It Observable. I would like, can you go back to the previous slide, by the way? Just quickly, because people are asking. Exactly, so Is It Observable? I will also put in, I think the QR code would always be good, but I will just post it in the Is It Observable into the chat here that everybody can see it. Yeah, and the typos are already fixed, by the way, because I see you are also now jumping on it. The thing is with, I think sometimes you have your French layout or your French language specified, and then PowerPoint doesn't correct it, but we fixed it. Whoever that was, anonymous, thank you for making us aware of it. But I think, Henrik, again, excellent explanation. And I think what people, just to summarize, I know you may go through the different questions that are already answered. A lot of questions were around how we can actually get observability into Kubernetes. We have the one agent operator, but there were a couple of questions on what if I cannot install the operator? What are my options to still get visibility? What type of visibility do I get if I can only do app injection? And then how do I get my Prometheus metrics? How do I get my Kubernetes metrics, the metadata? I think I tried to answer all this, but maybe also from your point of view, if somebody cannot install the operator for whatever reason, what are the best ways to ingest data into Dynatrace, what you showed today, and what can you do?
So the previous clinics that we had about open observability in Dynatrace will answer that question. So if you're not able to install the operator, there's a big chance that your Kubernetes operators has Prometheus or something similar. So why don't you deploy a collector from OpenTelemetry and put the scrap configs to the various exporter that you need. So kubestat metrics, node exporter, C advisor, all the metrics that I was showing you, those could be used. So the collector will get the metrics, send it back to Dynatrace. Again, it's going to be not collected by the operator, so the entity as we speak is not there yet. But with a new generation of Dynatrace with Grail, you will be able to do a DQL on metrics, DQL on lots of different assets, and build your own visualizations. But again, we are working on features to also consider the angle where the operator is not there. So we could maybe rely on external metrics like you mentioned. So, but today, yes, if you have this new generation or the second generation, once the metric is back in Dynatrace, then you using metric expression like I did with the OpenCost or anything will allow you to build the right visualizations and with the right KPI that you need to make decisions.
Mm-hmm. Then another thing, one question came in, is this also supported is this just SaaS, Dynatrace SaaS or managed? It's everything you showed today is supported in both, both SaaS and managed,
so
right? There's no difference.
It's not specific to the SaaS here. Everything that I showed you is generic for all the tenants of Dynatrace. So feel free to use it. Again, be creative. This is a message from the previous Observability Clinic. OpenCost is one of the angle that I took. And I think there is a question from Aaron Sims. OpenCost, do you know if you work on-prem? Yes, OpenCost, just to explain how OpenCost work, the billing of the cloud providers comes always at the end of the month. So which means if you want to have a live cost estimation, it's an algorithm. So it's estimate the cost based on numbers. And then this OpenCost, if you connect it to your cloud provider, it will get the billing information provided by GKE or Amazon or whatever, and it will adjust the cost from the previous month. But which means when you look at the live data that I was looking at, it's not the actual cost because I'm using GCP. It's going to be an estimated cost, but I don't care of having a precise cost. For me, like I said, I'm trying to figure out measure the efficiency and if I'm a good citizen or not on the way I'm deploying my apps. So you can use OpenCost as a KPI to drive how you want to optimize your workload for sure.
I also posted the link to the configuration of OpenCost on how you added the annotations on the OpenCost service definition to pull this data into Dynatrace. The link, everything that Henrik showed today, that you showed, is on your GitHub repository, right? I think. Yes, thank you so much for this. There's the question that just came in from Mohammed. Could you quickly explain the difference between cloud native and full stack injection mode with the operator? And I also try to find and post a link to the latest clinic, I think, where we covered this as well.
Yeah, so it's a question that we have quite often. So classic full stack and cloud native full stack, what's the difference? The classic full stack will inject the agent, but because we don't have any storage on your cluster, we need to reach out to a registry and to get the one agent installation, and the registry that has the one agent are the tenant. So which means every time you have a pod, there is an init process on the pod that will pull out this installation, deploy it. So at the end, the classical stack works, but sometimes if you're looking at the startup time of your pod, sometimes it takes more longer expected depending on the network that you have, or sometimes it's more challenging to manage. So the cloud native full stack introduced a new component called the CSI driver. So we map a driver globally on the cluster called the CSI driver, and all the components of Dynatrace has access to that volumes. And specifically if one pod is been scheduled, then one agent, we will get, if the image is not there, we will pull out the image of the one agent, store it on the CSI driver, which means the next pod that it will be started, it will basically pull out the image, which is local, so much more faster. And then there's a lot of other small features like through the storage of the data and so on, where we are more optimized and better in general. So at the end, if you have the options, I would say cloud native full stack is great. But again, sometimes depending on the environment, people doesn't like CSI drivers. So classic full stack will make the job. But if you're afraid on the startup times of your pods, then the cloud native full stack will resolve most of those problems.
Awesome. Then I think open cost, we answered this already. Then coming back to Joe, he had an additional question. I tried to explain with the operator and an HPA how this works, that Keptn is basically pulling in external data. And by the way, as you saw, Keptn is an open source project. It means Keptn is completely for free, right? It's a CNCF project that we donated to the CNCF. And one of the components is the metric server that is pulling in data from external observability platforms like Dynatrace, but I'm sure you also saw other logos on Henrik's slide. So even our competitors, if you have other tools as well, or any other external data source, you can pull this data back natively into Kubernetes and therefore provide it to tools like HPA, K8s, Argo rollouts, any tool that needs to make a data-driven decision back natively into Kubernetes. And I think that's great. The other questions, we had race conditions with classic full stack due to the frequent lack of availability of the binary. Could native work much better for us?
Yes, for sure.
Yeah,
because at the end it will be stored on the CSI driver, so you won't have that problem anymore.
Yeah, and then the application only monitoring mode. I mean,
so application only mode could work with with CSI driver or without CSI driver. So there's two mode. It's the same thing. The difference is that you have the active gate always with the operator. The active gate is there to interact with the Kubernetes API. So all the screens that we see here. All the screens that we see here in Kubernetes, the namespaces, they are coming from data that we're getting from the Kubernetes API or from CA Advisor metrics if you enable that feature. But if you do the app only, you only have the injection of the pod and you have no instrumentation of the nodes. You will only rely on what the Kubernetes API is giving you in terms of information. And sometimes if you are I'm going to close that problem. If you worry about your node, how does they behave? Dynatrace, when you enable the full stack, we analyze the node. So if you click here, I will get to the node screen, which is by the way, in fact, it's the new screens of the nodes, and you will see that you have much more details about which process, the network, and we have a couple of eBPF probe that we use to get the network traffic and so on. All those things comes with the infrastructure piece on the node side. And if you do app only, you don't have that at all. So sometimes, for example, in the screens, I'll show you Davis Insights. For example, here, if I have a large CPU load here and I want to understand why, if I do this, it will show me who is responsible for that. So I can see that it's my load test, which is responsible for this CPU load. And we can see that we have the front end doing the same thing. So it gives you more information, even if it's not at the container level, it's on the process level. You have lots of valuable information to help you to diagnose. Again, this is not mandatory. That's why we have different mode, but having the node instrumented sometimes is very, very useful.
Last question on this topic. You mentioned that we're pulling data in from the Kubernetes API. So if you cannot install the operator, you install basically the active gate on your Kubernetes cluster, and then the active gate is pulling the data in from the Kubernetes API, correct?
I never tried that. I'm not sure about that approach, to be honest.
How would you?
Because it's not a standard version of the active gates, not the traditional active gate that you may know if you work in the bare metal environment. It's a specific active gate that comes with more features, like I said, with the Prometheus exporter scrapping support and so on. So deploying it without anything else usually it doesn't work. It works with the operator. So I would say that if you want to have the metrics from Kubernetes, you will have to deploy the operator in any way.
Okay, and then the last, really, because it's at the top of the hour, is there something we can also use for AWS Fargate?
Yes, of course. It's a cluster. So at the end, Fargate will help you to deploy nodes and add extra, optimize the size of your cluster. But at the end, you still have a cluster and you can deploy as you want.
Awesome. And then if you want to know more about Dynatrace and Fargate, then you can also just use your favorite search engine and you'll find all the information. Henrik, again, thank you so much. The recording will be available hopefully in the next couple of hours on YouTube. And the dashboard also was asked. The dashboard is also on the GitHub repository that we posted earlier. There's a folder called Dynatrace. This is where all the dashboards are in. And the dashboard that you're seeing here right now, this is all out of the box. Everything here is all out of the box in Dynatrace. The dashboards that you used for your load test analysis and your Kubernetes cluster, that's stuff that you also have shared on the Git repository. And you're getting a lot of kudos and great jobs. Thank you so much, Henrik. And now enjoy your vacation because you earned it.
Great. Awesome.
Yeah.
All right.
Thank you, everybody.
Thanks, guys, for watching, and see you soon.
See ya.